Okay. Good afternoon, everyone. My name is Valen. I have 20 plus years of experience in various areas like development in networking, and I have a driver's experience. I have a embedded driver software low level on various system drivers like APGA, ASIC, and the last few years I have been working on AI systems, including the high performance computing, various hardwares like GPUs from various vendors from NVIDIA and Intel. I have other work environment with M2, Apple M2, and various other hardwares. So overall, I have a 20 plus experience in development, especially in a low level coding. So today we are starting a journey into one of the most exciting and fascinating field of AI is agentic AI systems. So over the next 40 or 45 minutes, we will move beyond a chatbot and simple question answering systems. We will discuss about Parinama offering on AI agentic systems. So in today's topic, so we will be covering mastering agentic AI. So this is just an introductory class. It's you can think it of as a webinar. So I will be walking through so what are the curriculums we offer as part of the mastering agentic AI. Okay, let's move on. So the class structure is designed 8 to 10 weeks. So mostly we will have 8 to 10 weeks. So each class will have a 1 hour 30 minutes, so roughly 90 minutes. So we will have a 40 minutes and 40 minutes, so 10 minutes break. So this class is only happens on Saturdays, either online or in person. So during this each class, we will have a 2 to 3 hands-on with various LLM models, especially OpenAI model or Gemini model or Anthropic. So I have pretty good experience on all the models. For example, GPT-4 or Gemini 2.5 Pro. So now Gemini has released 3.0 as well. So and we have a Anthropic system like a cloud systems. So all of them can be accessed via cloud API. So we will have a API. So for the each end models, we will be using those APIs to interact with Gemini model or GPT-4 model or the Anthropic model. So we have a various hands-on material available. So every class will have a 2 to 3 coding and hands-on. So what is the developer will do? What is the QA system guys or the operational guys or the new engineers like suppose they are looking for a job, they also can learn coding as well as how to set up the agentic model along with it. Yeah. So then finally, we will have a real world scenarios, especially in today's world. Everybody is eager to learn rack system and how to automate various tasks using the agentic AI. That's what we are going to do this entire the journey of the agentic AI. So today, most of us, we will be at the level one. So everybody knows nowadays how the AI work, how the chatbot work, how simple question and answering system work. But nobody has internal details or the programming aspect of AI. So and nobody, I mean, every engineers or every QA engineers, they don't know how to talk to the a system to get the response in a meaningful manner or the best out of the AI systems. So we will be talking about the concept in underlining in the mastering the prompt engineering technique. So I will be talking about a secret sauce or secret key how to communicate with the LLM models in deeper and then finally we will have exploration of retrieval augmented system. So we will go in deeper in a use case model and build a rack system and work with the llama model, and we can create the inferencing system so that it can work with rack system, and it can work with the LLM model. And finally, we will be building the various agentic systems. So I have a beautiful working environment. We can talk to our own Google Calendar or Google Gmail account, so they can automate your email systems with agentic AI. And then we will scale up your use case or your ideas, and finally we will have a various project. We will work with you to complete your task. Okay, this is the entire flow journey in the agentic AI. And coming to the what kind of the topics we will be covering on a weekly by weekly. So I will be talking about on the week one. So since everybody is new to the low level coding on the LLM, so we will start with the basic understanding where the AI stands, where the machine learning works, and how the deep learning work. And we will be talking about the different aspect of AI and machine learning, even the deep learning. So the deep learning, how to build a neural networks. So we will be talking about various architecture model, especially the transformer architecture model, how they are used in the Gemini and GPT model. So we will be deeper going into the transformer architecture for neural networks. Yeah. So especially in the first week, so it's like a kind of a theory, but we will have one hands-on item on the week one. Okay. So coming to the week two, so again, so we will be talking more closer to the LLM model topics, which is the data science, and we need to understand how the data science play a role in the LLM training, and we will be talking about the training stages, pre-training and training and post-training and fine-tuning, and how the inferencing model works, how the training model works. So basically, we will be talking about the staging techniques on the LLM. Okay, and finally, we will be touching the prompt engineering overview. But in week three, we will be covering like most advanced topic in the prompt engineering. So as I said in the very beginning, so secret sauce or secret formula for AI. So I will be going over the secret formula, how to extract the best out of best response from a AI system. So we will be covering like zero shots techniques and few shot techniques, and role play, and how to set the context, and various the prompts, like difference between the user prompt as well as system prompt, and what is the context memory playing in a AI systems. So basically we will be covering the most advanced topic on the prompt engineering. So that will be very useful for any developers or QAs or the even the operators or the new upcoming engineers. So they will be using these techniques to get the best responses. Okay. So coming back to the week four. So since the AI systems are mainly used in GPUs, so we will be having an analogy between CPU and GPU. So why we go for GPU? Why the AI systems are only suitable for GPUs? So we will be covering in detailed why GPU is better than the CPU. We also covering the how the GPU pipeline works, how the parallel computing works, and slowly we will be moving to NVIDIA. So everybody knows that NVIDIA is the market leader in AI, especially in the GPU technology. So we will go in deeper into the GPU architecture. So I like to, if anyone interested on the NVIDIA CUDA architecture, I will be covering the CUDA and Tensor Core architecture as well. And we will be we will be talking about CUDA toolkit, and how to extract the GPU information, and what kind of GPU you will be working on. So various GPUs from NVIDIA. So I will be talking about the NVIDIA GPU type as well. Okay. Coming back to the week 5, yeah, of course, this is the most fascinating week on week 5. So we will be having a hands-on experience. You will be creating a chat model. Basically, you have a chat window and you have an inferencing server you will create, and then in the backend you will have a LLM model like Llama 3.1. So you will be sending a request, and through the request is a chat window or some kind of a API. So either way, you should get a response from the backend LLM like a Llama 3.1. So the complete end-to-end model will be discussed. So in this hands-on, so you will be using NVIDIA T4 GPU. So definitely you will touch on one of the GPU systems. You will work on the chat system. You will work on the API, and on top of that, you will work on real model like Llama 3.1. Okay. So let's talk about the week number 5, and every week. So every week we will be covering like pre-session and the post-session. We will be sending some questions and task to complete on every week. Okay. So in this week 5, so you will be creating a API system. You will be creating a chat system. So you send a chat request, you will get the response, and you will have a Llama server, which is the inferencing server, will act as a proxy between the chat and the real LLM model, which is running on a GPU. So we will be using the D4 GPU in this case. Okay. So you will create the chat bot and you will create the API model. You will send a response, a request, and then you get the response. So you will really see what's happening in the real world LLM scenarios. Okay. Coming back to the week 6, it is going to be another fascinating week. So we will be creating a retrieval augmented generation, which is a rack system you will create. And we will have a use case, where do you use the rack and how do you use the rack and how to create the vector database. All will be covered in week 6. So in this week 6, we will extend the previous week 5 hands-on experiment to incorporate the rack system. So the existing system will be added to the rack system. Now the rack system will play for example, if you have a proprietary data, how the proprietary data will be augmented with LLM. So that's what we are going to talk about in the week 6. Today in this introductory session, so we'll have one hands-on. I will definitely do it for you guys, so you can try it. If you like it, you come back and work with us. Yeah. Okay. So what is the real rack system? So you have a new company called Gaudi Deco, some insurance company or something. So every LLM is actually have a fine-tuned cutoff date. So you have a model, you download it, but there is a new company in the internet. So the LLM is not tuned with a new proprietary company called Deco, right? So they have a various knowledge base, they have a policy documents, and so on and so on. When you send a prompt to the LLM says, I don't know anything. So now you have to create the rack system to get the Cardi Deco knowledge portal to answer your queries. For example, in this case, I have some query like I have a car insurance with you. What is the process to file a claim? So the LLM needs to get the response from the RAG. So how the LLM interacts with the vector database, new vector database, to answer the new query from the customers. So we will be creating something like a agent. So the rack agent will work with the LLM to answer the insurance queries like Cardi Deco. Okay. So in week 7, so again, we have a more practical use cases. So for example, you go to the Costco, you go to the Target, you have a purchase receipt. If you feed the receipt to the LLM, how to convert the receipt data into a JSON format or text format, or creating a podcast system. For example, you say, hey, I'm going to talk about some topic, create a 10 minutes podcast system, how to create it. So all the use case, like real world use cases, can be automated or created in week 7. So it's up to you guys. How do you work with me to get it the automated? Yeah. And coming back to the real world scenario, I was saying that in today's sessions, I will be definitely create this chatbot system, so you can see how I am doing it. You can try it out and then come back with various advanced topic. Yeah. And week 8, again, this is more advanced than the previous sessions, previous weeks. So in this week, we will be going more detailed into GPU architecture. So this is mainly on the programmers. We are willing to like work on the GPU systems or drivers level or low level. They can easily understand what is going on inside the GPU, how the text, for example, text or video or audio or any of the input data on the AI model is actually converted into decimal, like floating point numbers. So in GPU world, all the computation actually happens in a parallel, right? So how this entire text is actually converted into like a floating point number. Those floating point numbers will be given to a thread, and each thread how they work with other threads and creates the matrix multiplication or addition or subtraction or the division. What kind of operation we have in the mathematics, all can be achieved in GPU. So GPU is mainly for the computational purpose, right? So AI means what? Everything is computational. So we will more detailed or the advanced topic in the NVIDIA world. So because NVIDIA is the number one, I picked the NVIDIA GPU architecture in advanced manner. So I will be covering the CUDA programming, how to compile a CUDA or how to run the code and submit to into GPU. So, and especially you can understand how the GPU compiler work if you are a programmer. Of course, if you are a non-programmer, you can leave this item, or you can try to understand how the compiler work and how the GPU parallel computing work, or the how the serial pipelining versus the parallel pipelining work, and so on. So finally, we will demonstrate how a CUDA compiler compiles a program and makes the executable. From the executable, how to run it on a GPU, all will be demonstrated on the advanced topic. Yeah. So far what we discussed, so we have a workflow, we have I guess most of us very familiar on the first items. You give a user input, it goes to the large language model, you get the output. That's what everybody knows. But in the mastering agentic AI systems or the advanced topic, we will be having a rack system, we will be creating an agent. Also, we will create a agentic AI systems. So what is agent and agentic? So agent is a single task, and agentic AI is the completion of various tasks, and from the all the way from the input to the output, every agent work with other agents and completes the task. It's like a completely workable architecture is all about agentic AI. Yeah. So the week 9, so we may be talking on how to bring up the other LLM models. In, for example, if you have a Apple M2, or in your MacBook you have a MacBook having a M2 GPU or M4 GPU, how you can install the CUDA toolkit, and how to create LLM model work on your own laptop. So all those will be discussed. Also, I will be discussing on the SLM, which is the small model which can be useful for like a in your mobile. Nowadays, SLMs are very popular because you don't need a big, large language model, especially like a 30 billion or a 120 billion model for a complex task. All you need is a small task to accomplish. You need a SLMs. So how you create the SLMs on your mobile or in your small laptop, you can use it SLMs as well. Okay. Coming back the week 10, so we will be covering agent components. So complete the agent workflow. So what are the components involved, and what are the components are mandatory to build a agent? And we will be talking about the AI agent versus agentic AI, and we will be creating a complete workflow with N8 .ai, where you can create the no coding workflow, or if you want to do a workflow with coding, we have an advanced technique to create as well. So basically in this week we will be covering the AI agent creation, how to set the task, how to set the system prompt template, and have complete hands-on agent, and work with other agents. So that's what the week 8 all about. So let's move on to the complete agent. So agent, so normally you will have a like user query goes to the your LLM, the LLM gets and then gives a response. But in the case of a rack system or agent systems, you will have a query go to the you already have like you have a rack system created, so all the embeddings and vector databases are automatically created by another model. Yeah, that is the embedding model. You will have a vector database. You send the query automate, and simultaneously you will have a do a similar search on the vector database. So you will have a context setting and feeding to the LLM. You get the response. So these kind of agent we will be creating in these classes. Yeah. Okay. So I'm going to talk about few more things. So like in this entire workflow, so we will be in detail about the ChatGPT or GPT for communication flow. So we will be sending some text, how the text will be converted into embedding, and from the embedding, how the GPU send it to the LLM model, from the LLM model, how to get the output. All of them, we have a simulation as well. So I have a simulation. So the simulation you send the client will be sending to the text. It could be a text, it could be image, or it could be video, audio, whatever. So multimodal. So you going into the inferencing server. Once you send the inferencing server will embed the data into the LLM. Now the LLM will got the context. Once the got the context, so you will have to work with the GPUs, and you will run the LLM model, internal details of the LLM model. All we will be using a simulation model to understand better. For example, in this case, you send a send a query like how to reverse a string in a C program. For example, you are a programmer, you send a query to a ChatGPT saying that how to reverse a ring list. So how the entire flow works all the way from your window, your web terminal to inferencing server, from the inferencing server to the real world model, how the model converts the entire text into the token. From the tokens you get the response output. All of them we have a simulation, we have a working model, and we can also visualize how the LLM work. All of them I have. So for example, you say how are you tokenize, and from the tokenize you will have a embedding is nothing but you convert your text into some kind of a vector. So in GPU or parallel programming world, everything is called a vector. So you convert the vectors. From the vectors you will feed the vectors into the like a LLM model based out of a transformer architecture. So you send it to the tokenizer, and then attention. We will be covering like what is the tokenizer, what is the attention layer, talk about what is the feedback mechanism coming out of the LLM model, and then finally you get the output. So all we will be discussing in the simulation model basically. Yeah. And I have a simulation model for the rack system as well. So how the rack system work with the LLM, I have a beautiful like a simulation as well I have. So finally today, to end with, so I'm going to create a small demo, maybe a 10 minutes demo required. So in order to get the full understanding of the complete flow. So in the entire sessions, I will be using a G4 GPU. So I have a G4 GPU. So if you look at it, so I can connect. So let me connect it to my Um, you're seeing my screen, right? Yes.
Oh,
The
yes.
flowchart we are seeing here.
Okay. Yeah. Yeah. Okay. So now, so this is what I'm saying. So basically, we have a simulation environment. I can work with the Windows Jet GPT for communication flow completely. Internal details I can walk you through and make it understandable. Okay. So I have a how the internal LLMs work, large language model work. All the details I have it in a simulation way. Similarly, rack systems. So today I have something like how to create a chatbot with T4 architecture. So I have NVIDIA. Okay, let me see. I can upload. Okay, so basically, this is what we are going to talk about. Many sessions. I need to get it. Yeah, so it's connected to my T4 GPU. So you can have you can run it on the CPU as well as the GPU. So in this case, I'm running it on the T4 GPU. So if you have a paid account with the Google, so you have a GPU T4 GPUs, which is NVIDIA. I have a CPU as well. So we have a 5 TPU as well. So I am going to run it today with the T4 GPU. This is just a get to know that small demonstration. I want to show that how to create a chatbot system and work with real world model like a Llama 3.1. For example, this is the terminal window. I have set up instruction to install a Llama. So let me go back to the diagram I want to show you guys. Okay, so here I'm going to in the real world example, I'm going to use Llama 3.1. So you see my screen, right? What you're saying? Okay, so I need to switch to the okay. Okay, so this is what you see my diagram. Yes.
Yes.
Okay, so today I'm going to demonstrate I have a Llama 3.1 model, so which is going to run on a T4 GPU. So I will be creating a terminal. This is the text-based terminal window, so you can send a create and send a chat request. For example, you say, "How are you doing?" So when you send, the LLM inferencing server takes the text as an input, and then it converts the embedding and sending to the real world model like a 3.18 billion model. So this is the Llama is based out of Facebook. So they have a free Llama model I can download and then I can work with. So in this completely, this is based out of Python. So if you are very familiar on the CUDA architecture, even low level architecture, I can go about it. But in this scenario, we will be using the Python. So Python will be used as a the intermediate API module for connecting between the end user and to the model. Okay. Similarly, you can also use the API directly. You don't need a chat bot created. You can send a curl request, which is a API. You can send an API to the inferencing server. The inferencing server understands the API and converts the text or video or audio, whatever. It will be sending to the embedded information into the model. So the model will be executed here. You will get the response back. That's what I'm going to demonstrate now. So let me go back to the the system I have developed. Yeah. Okay. So in this case, so I will be installing the inferencing server first. So once I install the inferencing server, so I have a inferencing server is ready. So basically, I'm going to invoke the inferencing server. So the inferencing server will be listening on a port number 11 414. If you're a networking engineer or the any of the administrator, you will be knowing. So every server will be listening on a port. For example, a web server, it can be listening on a 443 or 80, right? Similarly, the Llama server, Llama, which is a Facebook inferencing server, which is a free to download. You can download anytime. You can download it from the internet and run it. it will be listening by default on 114434 port number, right? So that's what I have on the one terminal. It is listening on there. So now I will be installing one more. I need one more terminal to install my Llama 3.1 model, 8 billion model. I'm going to just install. So all the packages are installed. So now I'm going to execute my Colab XTerm. I need one more term. So which is the one more term I got launched. So now I'm going to pull real model. So this is what a real model look like. So I'm going to pull it. Let me copy. Huh? Okay, I need Olama. Okay, okay, I need to copy. Okay, I'm going to copy my. Okay, so I'm pulling the Olama 3.1 model, which is the 8 billion model. So we will be covering in the advanced LLM architecture topic, what is billion means. Here in this case, 8 billion. So we will talk about the internal details of what is billion means, how in the neural network world, what is the layers or input layers, hidden layers, output layers, and we will be talking about all of those. So bear with me in the real classes happens that time we will be talking about. So in this case, what I'm doing is I'm pulling the Llama 3.1 model, which is 8 billion. I'm pulling. So as soon as I have installing, so the Llama server, which is the inferencing server, knows that I'm downloading. So the inferencing server interacts with the Olama model now. So it will start accepting the APIs. Or so right now it's success. So Llama model we have created, we have installed the inferencing model. Now we have to start working on the chat model. So basically, you will be creating a chat window, which is the in the Facebook Llama model, they have created a library called Olama library. So you create the Olama library, you install, and you talking to the Olama inferencing server. So of course, every model we need some kind of a package. So in the Olama case, they give the Olama pip install library. So you will install successfully. Once you install in Python, everybody knows Python, right? So you need to import the library or import the module. So once you import the module, you can now talking to the inferencing server via the chatbot. So that's what I'm doing now. So I'm just importing the Olama, and once you import, all the APIs are available. So the APIs are nothing but you are talking to the Olama inferencing server with the Olama client. Now you can send anything you want. For example, this is my prompt. This is what really you will do it in the chat GPT chat window, where you say that my name is Parinama Academy, right? So you are just sending the prompt. In this case, you are sending the prompt via API. So I have created like a client is nothing but Olama client. You get the response is coming out, what kind of model I'm going to use, what kind of prompt I'm going to use, and then finally you print the response coming out of the model. So if I say something like, for example, if I say my name is something else. So for example, Parinama agent. So if I send, so the request number one will go here. So you will be able to see. So as soon as I see you will see all the meaningful information from the agent. So it will automatically knows that it's a Parinama. Parinama is from like in Sanskrit it is transformation, blah blah blah. So you can do anything. So these are the client API you will be sending to the backend LLM models. So as I said, right, this is the completely working on a T4 GPU, so NVIDIA GPU, so which is working on a CUDA. CUDA is a very famous toolkit by NVIDIA, which is nothing but a common unified device architecture. So common unified device architecture created by NVIDIA to work with the backend GPUs, right? So for example, in this case, I have given a command like write a C program to reverse a linked list. So it will give you a reverse linked list. So it says create a meaningful name, blah blah blah. So it is saying that I'm so on. So then I'm asking them what is my name. So looks like you gave a wrong answer. So these are the some trick questions you are asking the LLM via the APIs. So I'm going to send that. Yeah. So for example, if you say write a C program instead of C program, or you can say write a story, write a simple story for my 8-year-old daughter, right? So these are the uh, simple like prompt you will be sending in a real world GPT. Same thing, you will be programmatically sending the API to um, the the LLM in the backend. Yeah. So right now it sends all the prompt. Now it start creating a some simple story. Sorry, I didn't mean
Story
that.
spelling was wrong. Yeah.
Yeah. Okay, no problem. So it will be okay. I can stop anytime. I can send back the request again. So you are cutting a agent with a unique name, Paranama. So now it will be start doing some story. Yeah. So whenever you send, you will have like 200. 200 means in the programming world, it is successful. If it is a 500 means not found or something. So in this case, I have created a small story, Little Rabbit Big Adventure. So it says, oh, this is my simple story for you can say I want like a 10-minute story, I want like a 20-minute story, whatever. So the LLM will understand all going through like a request and response mode. So here what we doing each time we are sending opening client request and sending the client request to generate in the generate API. You will have a model name, you will have a prompt name. That's it. The prompt is syntax. Then you will get the printing the response from the response out of the client generates. Yeah. Okay, so that is all about, and even I can do many things. For example, what is backend is doing. So I can type 1 second. So I can copy this. Okay, sorry about that. Okay, better I can type. Okay, curl. Okay, now I can type. Curl. Curl is the like simple web programming API. So you can send HTTP localhost colon 11434. So if you say Ollama is running, so Ollama is the server is running. So you can say V1 models. So you can send a models. Also, you can send some APIs. You don't need to create a chatbot. So you can say, hey, I want to send some like streaming or non-streaming. If you are working with the real world application, right? So you can send. So basically, when I send, why the sky is blue. So basically, instead of sending any like programmatic Python code or something, you can directly send the API to the LLM server. So the LLM server will get the response in a moment. So basically, why the sky is blue is the prompt name. See, the prompt is that comes from the model Llama 3.1 million model, 8 billion model. So which is you get the structure of the OpenAI is like this: role, content, why the sky is blue is the actual prompt, and the actual content will be the actual content uh, from the llama. So instead of writing a simple program, you can say same thing in the chat model, like why the sky is blue. So instead of sending the in order to understand the OpenAI format, I just put in the API format. This is just a chatbot API format. So you just send. So again, the API will be executed in the backend LLM. You see here 200 OK means it is accepting. So once it accepts, it will give you the answer like a similarly what we send via API. So this is the API way. This is the chatbot way. So you will see in a moment. So exactly whatever the API way generated, you can also get the chatbot way. So it says what happens, sunlight enters, whatever. So this is the exact answer we are looking for. The sky is the blue, right? So the sky is blue, so and so. It has the detailed answer from the LLM. Yeah. Okay. So with that, I will be closing my sessions today. So basically, this class is mainly designed to you to understand what makes the AI agentic and why matters for all of us. And we will be covering the fundamental AI architecture and how to think about building your own agents. Basically, I'm sure end of this session or end of this entire class duration, you will be able to create your own agent or own AI systems or advanced computing engines or your own AI agentic systems, and you can work on the real world applications with the help of Farinama. Okay. Um, that's it from me. If you have any questions, yeah, I'm available for a couple of questions. Yeah.
Yeah, Velan, the first question is, we have Teja. She's completed her master's, okay, and she's looking for jobs, okay. So, can you explain her how this course will helpful for her career? What's after completion of this course, what sort of roles she can apply for?
Yes. So if you look at it, next few years, at least next 5 years, AI is going to rule the world. So if you know the internal architecture on internal detail of AI systems, this will be very helpful not only on your job profile, also in next 5 years, your profile is going to help along the way. So you are basically understanding complete AI architecture. So there is no someone I mean someone coming from the master or the you are looking for the job. This will be definitely helping you in your job profile. Also, you will be looking for some AI related job. This will definitely help you. Yeah.
No, what
So
sort of roles like, prompt engineers or something like AI engineer, what sort of roles she can apply?
So, for example, since you are very familiar, so you will be applying the inferencing engineer or
Mhm.
the AI training or the high performance computing AI system engineer, and you have if you want to go in the CUDA or the profiling area, so there is a high performance of CUDA profiling jobs in NVIDIA. And if you have a AMD or other companies, if you look everywhere, we have a various AI engineers are they are asking for, especially inferencing side or the training side or the high performance computing side or agentic side or complete the workflow management. For example, you are going to be some system you want to automate, so you can minimize like a 20 or 30% of the day-to-day work into the AI systems or AI agentic systems, right? So we can apply this entire knowledge into the workflow management. So it will minimize the even your personal jobs. For example, automate all your mails. Automatically, you can reply all your emails without any bothering your work, day-to-day work. So it will automatically reply and automatically schedule a meeting with someone and many more. It's just an example. So definitely the horse will help you along the way.
Yeah, thank you.
Yeah, welcome. Shiva, do you have any question on the?
No, I think it's a similar question, but more for people already in the field. You listed a couple of different roles. If you can, you know, um, articulate the specific roles, because you mentioned many different roles, right? So if you can give an overview, because all of us seem to know prompt engineer as one role, but the rest of it we are not really aware.
Yeah. So, for example, not only for the programmers, not only for the QA engineers or the operators, even the newcomers I talked about, right? So, this will be definitely the helping their job profile, and for the experienced people. So, day-to-day work, for example, they have a knowledge-based systems. They may have a design documents or they have a coding documents, all can be built, I mean automated, or their proprietary documents can be retrieved, or you can create your own knowledge based systems, and you can feed it to the LLM or local LLM and get the benefit out of it. Not only that, there are the like workflow management systems, agentic way, right? So you create the form, submit the form to the LLM. The LLM can be automatically writing or reading the Excel sheets, or writing the forms, or writing your design documents or templates. All can be achieved via the agentic way. Yeah.
Got it. And the follow up on that is, if somebody is in high school, right, is this a course that they can work on? Is it even useful for them?
Yes. So, of course, the AI knowledge is very beneficial for everyone for at least for the next 5 to 10 years. So, the world is going in a fascinating the field of agentic AI, right? So, everyone, so the sooner the better is actually good. So, I
But any
mean,
examples on what kind of roles, or is it similar, whatever you were mentioning?
yeah, similar. So if you look at any profile on the AI, so it will be either programmers, which will be high performance computing area, or the compiler area, or the inferencing area, or training area. Training means what? So you feed the new data and create the existing LLM to fine tune and get the better out of it, or good precision. So you have to have a good precision from a model. That's what the trainers will do. That's what the training job will do. So basically, you need to understand the aspect of the training stages, which we talk about in the course, right?
And I believe that's pretty much all I had from my end. Rajesh, anything from your end?
Yeah, I'm good too. Teju,
So yes, sir.
yeah, do you have any questions for Valen?
Sir, I wanted to know, would the course be low level, like where like people can me understand, or would it be high level? Like, sir was talking about few models before, llama, all those things where I could not get those terms. So would the course be low level where
No, the
mm,
course will be like a pretty easy. So I'm
mm,
talking about the Llama model is just a
mhm.
just a terminology, like a Facebook has the llama, right? Similarly, you must be working on the GPT, so you must be working on the Gemini. So today, how you are working on a GPT, right? So the chat GPT, you are in the end user window. So internally, how the end user prompt or the text or the video audio message actually sending into the backend. The backend can be anything. It could be a llama. We are not stick to llama, so we will be like every engineer's aspect we understand. So it could be a QA engineers, it could be a developer, it could be the like you newcomers. We will make you to understand. We will clarify in each class, and it will not be a very difficult. So that's why I'm saying. So we will go with the introduction and then slowly move on to the high level coding. So the coding, if you look at it, it's like a in the week 9 maybe advanced, or week 10 maybe advanced. So rest of them is very easy to understand, and it will be very easy to apply your day to day life. And